Hello. Today our lesson is about circumference and arc length. So we're talking all about circles here. Some of these, there's some new notation and new formulas today. So it does get a little complicated, but I tried to make your homework a little shorter to make up for it. So sorry about little long notes today. So let's go through some definitions real quick. Make sure we're all on the same page when we talk about circles and the parts of a circle. So a circle is a set of points all equidistant from a point which is the center of the circle. Okay, so set of points which are equidistant from the center of the circle. The radius is that distance from the center to the edge of the circle. Okay, so distance from center to edge. And then the diameter would be the distance from edge to edge that goes through the center. So distance from edge to edge through the center. Oops, sorry about that. And then the circumference is the distance all the way around the circle. So distance all the way around the circle. All right, so here's a little picture over here. So we see that the red is the radius, the D is the distance, and then the capital C is the circumference all the way around. So our first theorem today is the circumference of a circle, and it says the circumference C of a circle is pi d, or 2 pi r, where d is the diameter of the circle and r is the radius of the circle. Okay, so there's our formulas, and I think we've actually done some of this before, so this should be review. So let's go through some examples. So our first example is to find the circumference of a circle with a radius of 9. So because we're talking about radius, I'm going to use the version of the formula with radius. So I'm going to write down circumference equals 2 pi r. And my radius is 9. So I'm going to plug in 9 for my radius. And I'm just going to multiply 2 times pi times 9. Now remember, for pi, please use your pi button, okay, on your calculator. So locate that. I don't use pi button. Okay, please do not use an approximation. Use that pi button. So my circumference is approximately, when I multiply those two out. So my exact answer, this is great. Let's talk about exact versus approximate. So I'm going to multiply, if I multiply the 2 and the 9 first, I get 18 pi. And then when I plug that into my calculator, I get approximately 56.55. So please round to 2 decimal places. So the 18 pi, this is called my exact answer. And the reason is because in that symbol pi, I contain all of the decimals. They're all included. But when I actually multiply them together, I can't include all of those decimals because they go on forever and ever. And so I have to round at some point. And so when I do that, that's called the approximate answer. Okay, so when you include pi, that's the exact answer. And when you actually multiply those and give me a decimal, that would be the approximate. Okay, our next example is to find the radius of a circle with a circumference of 26 meters. So since I'm talking about radius again, I'm still going to use the 2 pi r formula. And in this case, I'm looking for the radius and I'm given the circumference is 26. So I'm going to plug in 26 for my circumference here and 2 pi r, and I'm solving for r. So remember, pi is just a number, so I'm going to divide by 2 and divide by pi. So then in my calculator, make sure you plug in, when you plug this in, you can plug this in into one step, but do 26 divided by, and make sure you put parentheses around your entire denominator. Okay, so you would write it like that. And when I plug that in, I'm going to get that the radius, so the 2's cancel, the pi's cancel. I get that the radius is approximately, oh, here, let's do it exact again. So if I was going to reduce this, 26 divided by 2 is 13 divided by pi. So that's my exact. And when I put that in my calculator, I get that the radius is approximately 4.14. And my units here, oh yeah, we forgot our units. My units on the first one were centimeters. And my units on this second example are meters. So make sure you're including your units. Great. Okay, let's take a look at the next example. The dimensions of a car tire are shown. To the nearest foot, how far does the tire travel when it makes 15 revolutions? Okay, so let's think about this. All right, so we want to talk about the car and a revolution. So let's talk about what is a revolution. So a revolution is basically if I put a dot of paint here on the tire and the tire rolls, and so the tire will roll, and it'll keep rolling and rolling, and then that dot of paint will hit again, and then it will hit again, right? So this is one revolution, and this would be one revolution, okay? So every time that dot of paint would hit the ground, it would be a revolution, okay? So a revolution is essentially one circumference, right? All the way around the tire, okay? So it's basically asking me how many are 15 circumferences, okay? So let's look at the information they give me. So one revolution, let's write that down so we remember. So if you want to put that in your notes, one revolution equals one circumference. Okay, so if I look at what they give me all of these distances here, which if I add them all up, I get the diameter. So for this problem, it would be smart for me to use the circumference equals pi times d, okay? And if I add all of those up, my diameter is going to be 15 plus, 5.5 plus 5.5 is 11, so 26 inches. Okay, so all of this is 26. So my diameter is 26 inches. So now I get circumference equals 26 times pi. And when I get that the circumference is approximately 81.88 inches. So I know one revolution is my tire is going to travel 81.88 inches. So 15 revolutions is going to equal 15 times 81.88, which is going to give me approximately, it's going to equal 1,225.2 inches. Okay, so if the tire rolls 15 times, it will travel 1,225.2 inches. And let's read our question, make sure we answered it. How far to the nearest foot? Our units are inches. We got to match that. So let's make sure we answer to the nearest foot. So I'm going to divide by 12. And I am going to get that it is approximately 102.1 feet. So that would be my final answer. Okay, next. This is where things get a little tricky and there's some new notation. So make sure you're paying attention. Ask me questions in the video chat if you have any. So our corollary is about arc length. And it says, in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio to the measure of the arc to 360 degrees. Okay, so what is meant by an arc? So basically, we have two things here. So we have arc length. So arc length is the distance of like the crust of a slice of pizza. Okay, so it's the distance of part of a circumference. Okay, and then we also have the measure of an arc. So measure of an arc. And so what the measure of an arc is that is the central angle. Okay, so that is the measure of the angle. Okay, so let's look at this. So when I talk about this, so the arc length of AB, so here's arc length of AB, that's talking about the distance of this little curved segment from A to B. And when it talks about the measure of AB, arc AB, that's talking about the measure of angle APB in this case. Now, why don't they say measure of angle APB? Well, they don't say measure of angle APB because, well, which angle are they talking about? Are they talking about that one or are they talking about this one, right? It's a little ambiguous when you use measure of angles. And when you talk about measures of arcs, we're always talking about the acute angle. Okay, so we're always talking about the acute, or not the acute angle, but the smallest angle. So measure of the angle, okay, we always talk about the smallest one unless otherwise specified. Okay, and we'll get to an example of what that means. Okay, so essentially what we're doing here is fractions. Okay, so I personally use this other formula instead. So if I look at the second formula here, so if I want to measure the arc length, remember that's the distance of the crust of the pizza, I can look at this and say, hey, I know that the whole circumference is 2 pi r, right? That's what this piece is here. So that's my circumference. That's 2 pi r. So that's the whole distance around. And if I know that angle measure, that central angle here, I can say, hey, that's a piece of the whole 360 degrees. So if it's 180 degrees, for instance, 180 divided by 360 is a half. And so I would want the distance of half of the circumference. Okay, so that's where that measure of angle or measure of arc AB over 360 comes from. It's just the fraction of the circle I'm looking at. Okay, so let's look at some examples. So our first example says, find the length of the red arc. And so I am looking for the measure of arc GH, or the length of arc GH. Okay, so arc length GH, okay, is going to equal, so I'm going to use this formula, my second formula here. Okay, so it's going to equal the measure of arc GH, remember that's the angle, divided by 360 degrees times 2 pi r. Okay, so let's go in and fill in the pieces. So the angle is going to be this angle here, so that's 120 degrees divided by 360 degrees times my entire circumference, which is 2 pi, and the radius is 11. And so that 120 divided by 360 tells me the fraction of the circumference I'm interested in. I'm not interested in all of it. I'm just interested in a fraction of it. Okay? And I can plug this into my calculator, and I'm going to get that it is approximately 23.04. And my units here are centimeters. All right, example D. I'm going to switch colors so we don't get confused here. So this notation right here, that is the notation for circle Z. Okay, so a circle with a little dot in it. And it says find the circumference of circle Z. So when I do this, I'm going to use this formula here. I'm going to use the proportion formula. Okay, so for this one, I have the arc length goes on the numerator, and in this case, I have the arc length of xy, divided by, and remember 2 pi r is the same thing as circumference, okay? So 2 pi r divided by circumference, and then I have the measure of the angle xy divided by 360 degrees. Okay, so let's go through and fill in the pieces. So my arc length in this case, so the arc length is that distance around just the part of the circle, is 4.19. I don't know what C is, that's what I'm looking for. And the measure of the angle of that arc is 40 degrees. So I have 40 degrees over 360 degrees. So when I go ahead and solve this, I get, I can reduce that fraction. 4 divided by 36 is 9. So I have 4.19 over C equals 1/9. So then I get C equals 4.19 times 9. And I get my circumference is approximately 37.71 inches. Awesome. Okay, I'm going to do 2 additional examples. And so if you want to turn the video off now and work on your homework, great. If you want to see some more examples, stay tuned. All right, so E. I need some space for E because I did not save myself space. I'm going to move this work up here. Okay, there we go. It is so nice to take notes on an iPad where I can just move things around. Okay, so example E says find the measure of arc RS. Okay, so remember this is talking about the angle measure. Okay, so I'm looking for this. This is the angle measure. That central angle. And when it talks about this, it's talking about the smallest angle. So I'm really talking about from R to S here. Okay, so this is the angle I'm talking about. This arrow that they gave me, this 15.1 or 15.28 is my radius. Okay, so let's set this one up. So I'm going to go ahead and use that proportion again. So I have that the arc length of RS over the circumference, which is 2 pi r, is going to equal the measure of that angle, RS, of the arc RS, over 360 degrees. All right, so if I fill in my pieces here, I have that the arc length is 44 meters. The circumference, I don't know, but I can figure it out because they give me the radius. So 2 pi times r, and the radius is 15.28 meters. I don't need to put the meters in there. Let's erase that. And then the measure of the angle, that central angle, I don't know. That's what I'm looking for. So measure of the central angle of arc RS, put there, divided by 360 degrees. So now I can multiply both sides by 360 degrees to cancel out that 360 degrees, because remember, I'm solving for the measure of the angle. All right, so I'm going to multiply by 360 degrees. And so 44 times 360 divided by, and make sure you put parentheses around your entire denominator when you divide all that. Okay, so I'm just going to plug all of this into my calculator into one step, and I am going to get approximately 165 degrees. And that is about the measure of arc RS. All right. This next example, story problem. So exciting. I love story problems. So this one says the curves at the ends of a track are shown are 180 degrees. Okay, so 180 degrees, you should think semicircle, half circle. Yay, we like that. half circle. The radius of the arc for a runner on the inner path is 36.8 meters. The radius of the arc on the outer path is 44.02 meters. How much farther does a runner travel on the outer path than a runner on the inner path when they go once around the track? Okay, so we have to do both the path for the inner and the outer. All right, so let's figure this out. So if I look at this, essentially what I have is I have half a circle here, half a circle here, and then I have the inside. So if I figure out the circumference of a circle and add it to 2 of the distance on the inside, which is 84.39, then I can figure it out, okay? So let's talk about the inner path. Ooh, the inner path is red, so I'm going to use pink. Okay, so my circumference of that circle, so circumference is 2 pi r. So the circumference is going to be 2 pi times 44.02, which gives me, let's see here. Oh, that's the outer path. I picked the wrong number. Not 44.02. It is going to be 36.8. Okay, so the inner path is circumference. And then plus, let me just do this all in one step. Why not? Why not do it in one step? So I got my circumference plus 2 times 84.39. Because they have to run that stretch twice. And so when I do that, I'm going to get that the inner path is approximately 400 meters. Hey, that's great, right? 400 meter track. And so let's talk about the outer path now. So the outer path is blue. And so the outer path, we would do the same thing. So we get 2 pi r plus 2 times that 84.39. And in this case, my pi is 44.02. And so now, I did not figure this one out yet. So 2 pi times 44.02 plus 2 times 84.39. Sorry, I didn't pre-calculate this. Is approximately 445.37. So my answer would be, if I want to know how much farther does the runner travel on the outer path, so my answer would be about 45.37 meters farther. Okay, great. So go ahead and try the homework for tonight. Practice the new notation. Email me if you have questions. I will also be available on the video chat during class, or if you want to hop on the video chat during office hours or something like that, just email me and let me know. I'm available. All right, bye.